Hey everyone.
Whoa.
Hi, I'm Mike. This is Talal and Josh.
Hello.
Between the three of us, we've got about 9.5 years of LookML experience. So we've survived a lot. But we're going to share with you guys all of the pains and lessons that we've learned with our favorite language, LookML. Yeah. Wait, before we start though, let's ask some questions. Yes.
Yeah, absolutely. So just a quick poll in the room. We thought we'd start by getting an idea of where everyone was. Who here's been writing LookML or using LookML for more than 3 years? Couple people in there, you got it maybe. How about like 2 years? That's where I fall. 1 year? Anyone been using it for less than a year? Okay, awesome. So we got a little bit of everything in here.
Wow.
Let's grab these. The next thing we thought we'd do, being data people and not knowing how to use the clicker, is do a little bit of data improv. So we love working with numbers. So we're just going to kind of throw out some numbers, and they all relate to LookML or LookML development in some way. And we just kind of want to see if you guys can guess what they mean. So the first number here is 2,223. Anyone have a sense of what that could mean as it relates to LookML or Looker?
This is the year that Looker is going to create a word cloud visualization.
It's later than that. Any guesses? So these are the number of models that have been created, 2,223 models. How about 4,042? Any guesses? No? Explorer objects? No?
Ooh, that's good, explorers.
So these are the number of committers. So these are the people that are committing LookML code. How about 255,366? Views, explorers, I heard, no. And what was it? Yes, commits. Exactly. If you see support, get your swag. And then finally, 693,843.
There we go.
Lines of code, that's correct, yes. And that is not collapsed, that's uncollapsed.
Yeah, so LookML is a fairly lightweight language. We don't have a lot of safety rails. It's not heavy or bulky like traditional data dictionary languages. And I think the reason for that was because Lloyd was a very generous and benevolent language designer. When he was making LookML, this is actually true. When he was first making LookML, I think he really assumed that we were all very wise and very smart, and we'd always do the right thing. And then I started working in LookML, and probably ended up disappointing him a lot. But LookML is so expressive and powerful, it can practically do almost anything. But just because it can do anything doesn't mean we should do everything.
And one of the things that we work really hard on at Looker is coming up with the best practices. It's learning internally, using the language, learning from our customers, and trying to teach and educate both ourselves and everyone that's picking up the language. And in fact, one of the things that we're prioritizing as a team is to create a book, to create the best practices on how to unleash this really, really powerful, expressive, flexible language, as Mike mentioned.
Right. So this project on writing the book all started with essentially, one day a bunch of Looker analysts got into a room with a big whiteboard and started writing down all the qualities that make up a good model. And then we got an even bigger whiteboard and started talking about all the qualities that make a really bad LookML model. And a lot of you, I thought I should actually mention, a lot of you saw like the release of the new LookML. The stuff that we're talking today is really going to be, has nothing really to do with the new LookML or the old LookML. These are sort of guiding principles that you should really just think about as you're developing your LookML model. And the way that we started thinking about it was, every model is completely different. You can do so much. Everyone's underlying database is so different that how do you come up with these guidelines that are going to span across so many different potential data schemas. And so we started off with some priorities.
Yeah, so we looked at the list of all the things that make a model great, and we came up with 5 main things. The first thing is maintainability. So when you're looking at your model, one of the things I like to think about is a year out from now, will I still be enriching this model? Will I still be extending the data it has access to? Will I be accomplishing new analytical use cases? Or is this model going to be on life support? Am I going to be building PDTs all the time? Am I going to be fixing fields that no one uses? Are there going to be bad measures that doesn't make sense anymore for the business? So maintainability is key, making sure that we can build something that scales. The next point is the UI and the UX of the model for our explorers and also our data consumers. The model itself is what drives Looker, and the developers have to plan for how every other user is going to play with Looker. So we have to build something that makes sense. The third thing is activation and onboarding of new developers. We need to make sure that the model maps well to the data, so that way it's obvious to know what this part of the model is doing. So this helps organizations scale with new developers, or you're just looking at really old code that you haven't touched in a while. You're aware of where it's coming from. And then there's clarity and brevity. This is a standard software development practice. Don't increase the cognitive overload of reading code, writing code, and especially debugging code. And finally, query performance. We want our queries to run, and we want our databases to not crash.
Right. So yeah, we'll start with a couple of these guiding principles that we ended up with, sort of based on those priorities. And the first one is actually, it's not really unique to LookML development. This is a really common concept in all software development. And it's the concept of not repeating yourself. So if you ever find yourself writing the same line of LookML multiple times in your model, there's probably a better ways to do that. And so, you know, LookML has a lot of tools that you can use so that you don't have to repeat yourself, so that you can reuse existing bits of code when you need to. And so I'll walk through a couple of examples of what these are and why they're important. The first one is the substitution operator. You guys have all seen these little curly brackets and the little $ mustache bracket thing. This is one of the most important aspects of Looker, because this is what's going to really give you that maintainability of your code and ensure that single source of truth. The single source of truth goes beyond just having a single measure or a dimension for the front-end interface, and it goes to, you should only have a single point of definition for any piece of business logic within the model itself. And so I'll walk through sort of some examples here of some ways that we see people misusing the substitution operator. So the first one is, a lot of times, you know, when you run the default generator, you get, you know, by default, you get a dimension for every column in your database. And a lot of people's first instinct is, oh, hey, this shouldn't be a dimension. I want to aggregate over it. This should be a measure. And so they go in there and they change the dimension to a measure, and they make a type sum, and they leave that underlying sort of reference to the table.price column in the measure itself. Really, a better way to do it is to actually keep the dimension as is and create a separate measure that references that dimension. And if you don't want to expose that dimension, that's fine. You can actually hide it. But the reason that this is really important is because I want to be able to reference that underlying schema multiple places in my model. If I want to do an average price, if I want to create other dimensions or other measures that reference that underlying column, I want that to be in a referenceable place in my model, so that if in 6 months, for whatever reason, I have to make a change to that underlying schema, I'm not going to have to go figure out everywhere in my model where I reference that underlying schema. I've only got that one point of entry. And so once you have these a use of the substitution operator basically allows you to think in building blocks. And so this is another thing that we see really commonly, which is people will embed multiple pieces of business logic into a single dimension or measure. And really what you want to do is you want to break it down into sort of the lowest common denominator, the lowest base point. If you can go back,
Oops, sorry.
Mosk. Well, forward, yeah. This is an example of, let's say you're looking at an opportunity in Salesforce. If you guys have used Salesforce, essentially what we're looking at here is there's two different parts of this. I want to understand, I want to be able to reference all of my opportunities that have closed in less than 60 days, right? So I've created this yes/no dimension that has this logic built into it. It's looking at two things. The first line there shows a date difference between the start and end date being less than 60 days, so that's checking one thing. And the next line is defining what a closed opportunity is, meaning the stage name is either close won or close lost. But really these are two completely different things. One is telling me how long it was open, and the other one is telling me whether or not it's closed. But they're both embedded, both of the logic's embedded that. So the better way to do this is actually breaking those out into separate components, having a separate days open, creating a separate is closed, and then referencing those underlying building blocks within my is closed in 60 days. And what happens when you do that is I can now use those different pieces of logic in other places in my model. That is closed field. I can create a filtered measure to count only my closed opportunities on it. I can use it as a filter. Again, if I don't want to expose it, I can hide it, but I still have that reference point because let's say, down the line we change our stage names to be something totally different. Again, I only want to have to go one place in my model to update that logic, and that's going to flow through now to every dimension or measure that references it, every dashboard and report. I'm not going to have to go back and worry about sort of like the, if you think about it in more of like a library of SQL queries, you got to go back and remember like, oh, where did I use this closed logic, and kind of go through line by line and make sure you didn't do it. That's exactly what you want to avoid. And then the last example I'll talk about here is using extensions. So who here has actually used extensions in their model? Okay, a couple of you. So extensions, in my opinion, are one of the most powerful but underutilized features in Looker. And if you haven't used them, I really encourage you to go read about them about them like in a little bit more depth. But I'm going to cover the basic concept here. Really, the whole purpose of extension was to enable this idea of not having to repeat yourself. It's about taking pieces of LookML and extending them so that you can either add to them or tweak them, but without having to repeat yourself. And so you can either do this on a view basis, where you extend a view and then reuse its fields for another use case, or you can use it on an Explorer. So here's an example of how I would extend an Explorer. Let's say I have a super normalized schema, right? And I've got a bunch of different tables that have attributes about my user, right? I have a user base table, I have a user profile, I have user fact, I have user address. But I want to carry these attributes with me everywhere that I bring my user table into my model. So rather than defining these joins on every Explorer where I want to bring in my user, what I can do is actually create this base Explorer here that's you can see that extension required. The whole purpose of this Explorer is for me to go reuse it in other places. And what I can end up doing is, now when let's say I want to create an orders Explorer and I want to bring in all those user attributes. Rather than redefining all of those joins, essentially what I'm doing here is I'm extending that user base Explorer that we just saw. And what that's going to do is it's automatically bringing in all of those other joins that we saw. So I don't have to redefine the joins here, and I can also reuse this again. Let's say I want to bring in users to my Sessions Explorer, same idea. I can reuse that. Now it lives in multiple places. If I want to bring in more attributes to that base user Explorer, again, I'm going to one place, updating the join logic, adding in more joins, changing what fields are exposed, and I'm not having to redo it here. And then one thing I'll add is, sometimes it's hard to kind of find this like universal across the model thing, but part of the way that extensions are used is you can actually override let's say for one specific Explorer, I want 2 or 3 of those joins instead of all 4, you can actually override that on an Explorer by Explorer basis. And yeah, I think those are the examples.
I think like conceptually, you're kind of modularizing those relationships and then carrying them throughout the model and not repeating that join logic over and over again.
Right.
The other element is the view extension too. So taking a certain view orders and then extending it maybe for marketing, and they have all their fields in that extended version. As a developer, if you go back and you edit that base view in this concept, it's the one that's being extended, the extended view, that will carry over to the rest of those extended views as well too. So definitely something to explore further.